All right, my dog finished her supper and now she is playing with a milk jug, so you'll probably hear her in the background, but she's so cute, so we let it slide. All right, for topic 2, we're going to look at adding and subtracting unlike fractions. So remember from the previous video, unlike fractions are fractions that have different denominators, okay? So the big thing is when you're adding fractions, you have to have a common denominator. That is absolutely essential, okay? So when you are presented with a situation where you have two fractions that don't have the same denominator, you need to find a common denominator. So step 1, find the LCD. Step 2, once you find the LCD, you want to find an equivalent form of each fraction using the LCD. There's a little typo here that should say and, not and. So find an equivalent form of each fraction using the LCD. Step 3, add or subtract the numerators, keep the common denominator. So this is just like the previous section. And then at the very end, you look to see if you can reduce. So find your LCD, find equivalent forms, add or subtract your common or your like fractions, and then simplify at the end. Okay? So example 2 here says find each sum or difference, simplify your answer. So first we have 2/7 plus 8 over 21. So you need to find an LCD. There are so many ways to find LCDs. Really, some people just kind of play around in their head until they find something. You could do the prime factorization method, you could do the multiple method. Just find your LCD some way or another. So in this case, I'm going to kind of do the multiples method, but it'll work itself out very nicely. So if I start listing out multiples of 7, okay, I have 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. So one thing you can do is you can always look to see if one of your denominators divides into the other evenly, and then that makes it easy. The larger denominator is your LCD. So that's what's happening here. So again, if we wanted to list out factors or multiples of 7, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, we can stop because 21 is the other denominator. So the LCD here is 21. Okay, now we need to find equivalent forms of these fractions. So for now, since we're just learning this, I'm going to do it very separate, like I'm going to do different pieces and then build this problem. There are times where when you get comfortable with this, you can find your equivalent form sort of in the body of the problem. We're not going to take those shortcuts yet, okay? So let's start with 2/7. We know we want this denominator to be 21. So we ask ourselves, what would I multiply 7 by to get 21? Well, I would have to multiply top and bottom by 3. Remember, we're really looking for some form of 1 that we can multiply 2/7 by. So that happens to be 3/3. Well, 2 times 3 is 6. 7 times 3 is 21. So I get 6/21. That's my new fraction. So this problem is really 6/21 plus 8/21. I now have a common denominator, so I have what's considered like fractions. And at this point, we just add the numerators and keep the common denominator. So this becomes 6 plus 8/21. Well, 6 plus 8 is 14, so I get 14/21. And at this point, when you're adding and subtracting fractions, you always simplify at the very, very end. Okay, so I need to find a common factor between 14 and 21. And I know it happens to be 7. Okay, so we could think of 14 as 7 times 2. We could think of 21 as 7 times 3. If I write it out like this, it's really, really easy to see that common factor that we're dividing out. So we're dividing top and bottom by 7. And that just leaves me with 2/3. So 2/7 plus 8/21 is equal to 2/3 when simplified. Okay, let's look at another one. So next up for part B, we have -1/5 plus 9/20. So we definitely do not have common denominators. But if you look here, we have a situation in part B like we did in part A. Winnie, honey, you have to stop. Okay, so if you look at your denominator of 5, it goes into 20 evenly. So if you ever have one denominator that divides into the other evenly, the larger denominator is the LCD. So if we want to go ahead and list out factors, or not factors, but multiples of 5, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. So we can stop there. We've got a common denominator. So we can say the LCD here is 20. Okay, so let's find an equivalent form. So I need to work on -1/5. I'm going to rewrite it as something over 20. So I have to ask myself, what would I multiply 5 by to get 20? Well, that would be 4. So I want to multiply top and bottom by 4. That's my weird form of 1. So -1 times 4 is -4, and then 5 times 4 is 20. So I've got now an equivalent form of -1/5 that happens to have the LCD as the denominator. So let's just rewrite this whole problem. So my first fraction was -1/5, which we now know is -4/20. We want to add that to 9/20. So anytime I have signs, I just float everything to the numerator. So this is going to be -4 plus 9 over 20. Well, -4 plus 9, that's adding two integers that have different signs. We really subtract. So we want to find the difference between the positive and the negative. So 9 minus 4 is 5, and then we have to ask ourselves, is this going to be positive or negative? So I have 4 negatives, but I have 9 positives. So that tells me my final answer is going to stay positive. So this is going to be 5 over 20. Well, let's see what this looks like. I know that if a number ends in 5 or 0, it's divisible by 5. So I could rewrite 5 as 5 times 1. I could rewrite 20 as 5 times 4. It's really easy now to see the common factor that you could divide out. So we divide top and bottom by 5. We're left with a 1. And that gives me my final answer is 1/4. So -1/5 plus 9/20 is equal to positive 1/4. Okay? Let's look at part C. So for part C, we have 5/7 minus 9/10. And unfortunately, that little trick that we were able to use in A and B with just knowing that one denominator divided into the other evenly, it's not going to work here. So let's start listing out multiples. So we have 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 7 times 10 is 70. I'm going to stop there. Now let's do the same thing for 10. So 10 times 1 is 10, times 2 is 20, times 3 is 30, times 4 is 40, times 5 is 50, 6 is 60, and finally, hopefully you can see the writing on the wall here, 5 times 7 is 70. So we have an LCD. So the LCD for this problem is 70. Okay? So let's get equivalent forms of these fractions. So I have 5/7, but I know I need it to be something out of 70. So what do we multiply 7 by to get 70? Well, we would multiply by 10. So I want to multiply top and bottom by 10. Remember, I'm really just multiplying by a weird form of 1, so I'm not changing the value of 5/7, just its appearance. So let's see, 5 times 10 is 50. So I get that 5/7 is equal to 50/70. 50/70. All right. Now we have 9/10. We want to convert that into something over 70. So what would I multiply 10 by to get 70? Well, I'd multiply by 7. So I'm going to multiply top and bottom by 7. Remember, that's just some weird form of 1, so I'm not changing the value of 9/10. So let's see, 9 times 7 is 63. And then 10 times 7 is 70. So I've got two new fractions here, so let's rewrite the original problem. So we know that 5/7 is really 50/70. We know that 9/10 is really 63/70. So now we get 50 minus 63 over 70. Now, if you need to do side work for the numerator, that is fine. There's no shame in side work. So off to the side, we have 50 minus 63. Back in the previous chapter, when we were adding and subtracting integers, we found that we could convert this to addition. So this would be 50, and then instead of subtracting positive 63, I want to do the opposite of both. So the opposite of subtraction is addition. The opposite of positive 63 is negative 63. So now we're adding two numbers that have different signs. So we want to find the difference in the positive and the negative. So I would subtract. 63 minus 50 is 13. But is this positive or is this negative? So what did I have more of? Did I have more positive or did I have more negative? Well, I only have 50 positives, but I have 63 negatives. So those leftover negatives stay in this final answer. Okay? So I'm going to come back down here and I get -13 over 70. And we would want to see if 13 and 70 have any common factors. So 13 is prime, and 13 is not a factor of 70. So we can say that this is our final answer. Okay? One more. So we have 5/8 minus 1/3 minus 1/12. So we need to find some kind of LCD. So let's say for the sake of practice, let's do the prime factorization table. So looking at 8, I need two numbers that multiply to give me 8. So that could be 2 and 4. Well, 2 is prime, but 4 is not. So 4 should be written as 2 times 2. Now, 3 is prime already, so we don't need to do a table for that, but we do need to remember it's a factor here. So let's just scoot over to 12. So we need two numbers that multiply to give us 12. Let's say we do 2 and 6. So we get 2 times 6. 2 is prime, 6 is not. So we want to write 6 as 2 times 3. Now, when I do my prime factorization table, I need a row for each denominator. So I've got a row for 8. Don't forget you had a denominator of 3. And then I need a row for 12. And I need a row, finally, for the LCD. So 2, we already know is 2 times 2, or 2. I'm sorry, 8 is 2 times 2 times 2. I want to fill in factors for the other two denominators as much as I can in these three columns when possible. If not possible, I just start a new column. So 3. My second denominator is 3. Its factorization is just 3. So unfortunately, I cannot put 3 in either of these 2 columns. So I need to start a new column for my 3. And then for 12, I have a 2 that can go in the first column or the second or third. I have another 2 that can go in either the second or the third columns. And I have a 3, so that can go in that fourth column that we created. So remember, the number of columns tells you the number of factors in your LCD. So to figure out what the actual factors are, you just bring down the representative from each column. So I have a 2's column, that means a 2 comes down. I have another 2's column, that means another 2 comes down. I have a third 2's column, so a third 2 comes down. And then finally, my last column was a 3's column, so a 3 comes down. So let's see what this all multiplies to. So 2 times 2 is 4. 2 times 3 is 6. So my LCD ends up being 24. So there you have it. That's the LCD. We still have some work to do though. So let's find our equivalent forms. So let's start with 5/8. So we know we want to rewrite 5/8 as something out of 24. So we ask ourselves, what would we multiply 8 by to get 24? Well, we would multiply by 3. So top and bottom by 3 gives me 15 24ths. Next, I have 1/3. So I ask myself, what would I multiply 3 by to get 24? That would be 8. So I'm going to multiply top and bottom by 8. So that gives me 8 24ths. And then finally, we have 1/12. So we ask ourselves, what would we multiply 12 by to get 24? That would be 2. So top and bottom get multiplied by 2, which gives me 2 24ths. So now we're just going to rewrite the whole problem. Okay, so 5/8 is really 15 24ths, minus 1/3, which is really 8 24ths, minus 1/12, which is really 2 24ths. So that's going to become 15 minus 8 minus 2 over 24. So let's do the subtraction. So 15 minus 8 is 7, and then 7 minus 2 is 5. And 5 and 24 do not have any common factors. 5 is prime, so the only factors of 5 are 1 and 5, and 5 is not a factor of 24. So we're done. So there you have it. That is adding and subtracting unlike fractions. So you need to remember that you have to find the LCD, you have to find equivalent forms. You then can add or subtract your numerators, keeping your common denominator. Simplify at the very, very end. Okay? So that's it for adding and subtracting fractions. In the next videos, we will look at comparing fractions, putting fractions in order, and I think evaluating expressions that have fractions in them.